Hello and welcome back. Today we're going to be talking about section 3.1, which is all about reviewing properties of exponents, and also we're going to be talking about polynomials. So let's start first of all with our properties of exponents, and like I said, this should be a review for you. So if you find that going through the examples that we do is not enough, make sure you reach out and do a few more examples or watch some other videos, because this is really important to know for what we're going to be doing in this class. Okay, so looking over some of these properties of exponents. So the product rule is when we have terms with exponents that have the same base, then we're going to add those exponents together. All right, so those bases need to be the same, connected by multiply, then we'll add those together. Similarly, down here with division, so the quotient rule, when we're dividing terms with exponents that again have the same base, we're going to subtract the exponents. Now notice that it is the top exponent minus the bottom exponent. The next one is the power rule. So when you have a power raised to a power, like we do here, then we multiply those exponents together. On this one, we can see that we have two things inside, right, that are multiplied together, and we need to make sure that we give that exponent to both of them. So we need to raise the a to the nth power and also raise the b to the nth power. Okay. Then the next one, the exponent of one rule, so that just means any base that is raised to the first power, it's just going to come back as itself. So with the zero exponent rule, anything raised to the zero power is 1. But we can't have a equal to 0, because 0 to the 0 power is actually indeterminate. All right, and then the power raised to a quotient, so we've got something inside connected by division raised to a power. Again, we want to make sure we give that power to both, everything on the top and everything on the bottom. And again, b can't equal 0 because we cannot divide by 0, so we've got to be careful with that. And then our negative exponent rule is when we have something raised to the negative power, we're going to flip it. We take the reciprocal of it to make it a positive exponent. And so notice on this one, when we flip it, that a to the n goes to the bottom. And on this one, the negative started on the bottom, the negative exponent was on the bottom, and now it flipped up to the top. Okay, so that's kind of the way I like to think about these negative exponents, is we want to flip them to where they're going to be happy, right? So if they're negative, they're not happy where they are. If it's unhappy upstairs, we're going to flip them downstairs so they're happy. Or if they're unhappy downstairs, we're going to flip them upstairs to be happy or positive. We want to always end up with these positive exponents in our answer when it's totally simplified. All right, so now that we've reviewed over those, we're going to put them into action and do some examples with them. If you'd like to read through these examples on your own, you can, to get used to the rules that are being used there, these properties of exponents. But let's go ahead and work through this first problem. All right, so you'll see on part A, we've got y to the 4th power multiplied by y to the 10th power. So when we have something that is connected by multiply, we need to add those exponents together, right? So we're going to have y to the 4 plus 10 power, which really gives us y to the 14th power. All right, let's look at the next one. Okay, so on this second one, on part B, we've got negative, all right, on the outside, times 8 to the 0 power. So that negative out in front, I'm going to write down as a -1 because that's really what it is. being multiplied by this other part? Well, let's figure out the other part. 8 to the 0 power, anything to the 0 power is just 1. So I've got -1 times 1. Plus, now let's look at the other one. On this one, our negative is on the inside, not the outside like it was here. So -6 all raised to the 0 power is going to be 1. So now let's look at this and simplify this more. -1 times 1 is -1. And then plus 1 is 0. So we end up with 0 for our answer there. All right, let's take a look at part C now. On this one, it's connected by division. So we're going to use that quotient rule. And it said when we have these connected by division, we're going to subtract the exponents. Right? So I have y to the 3rd power minus 5. It always needs to be the top exponent minus the bottom exponent. And so that's going to give me y to the -2 power, but we can't leave this as a negative exponent, and so we need to use that reciprocal rule where we're going to flip this because it has a negative exponent. So I'm going to put a 1 underneath that just to make sure it's clear what's happening here. So that 1 is going to go to the top, so I'm doing the reciprocal of this, and when I move this to the bottom, it actually changes that to a positive exponent. So I end up with 1 over y squared. Hopefully that was helpful for you in reviewing these properties of exponents.